Hello. All right. Finally. All right. So the audio is clear now, I hear. Okay. So we are going to discuss the physics paper of CBSE today. All right. What we are going to discuss today is set 1. We are going to discuss set 1. Okay. So let us go through the paper together. Let us see some questions, some numericals, what they have asked. Okay. And let us see the paper, the level of the paper, whether it is too difficult or too easy or moderate. Okay. Let us see this together and decide. So initially they have told us that the paper contains 33 questions. Some are optional, and they have given us the values of some basic parameters like speed of light, Planck's constant, etc. The paper has been divided into 5 sections: A, B, C, D, E. Okay. And in some sections there are choices between the questions. All right. So let us begin with section A. Let us begin this with section A. Okay. So in the first question, they have given in a region the electric potential varies as. So the first question they have given the potential value, the expression 10 minus 50x, where V is the potential in volts, X is in meters. Okay. Now they are asking us the electric field in the region. So it's quite easy. So we know electric field is given by minus del V del X I cap. Then there is minus del V del Y J cap minus del V del Z K cap, but we do not need that obviously because it doesn't contain Y or Z terms. We just need to differentiate this. So so this is the answer. So the first question, electric field is 50 and it is directed along the positive x-axis, not the negative x-axis. Okay. So option D, sorry, option C. Option C seems to be the correct answer here. Next question. This is a fairly simple question. Okay. The first question, very fairly simple, quite common question. The next question: a conducting wire connects two charged metallic spheres A and B of radii R1 and R2 respectively. Distance between the spheres is very large compared to the radii. Just a second. Yeah. Distance between the spheres is very large compared to the radii. The ratio of electric fields at the surfaces of spheres A and B. Okay. So second number question. They are saying a conducting wire connects two charged metallic spheres A and B. So we have two charged spheres A and B of radii R1 and R2. Alright. And a metallic wire is connecting both the spheres. That means they will have the same potential. Okay. They have given us indirectly, they are going to have the potential of A and B will be same. And the distance between them is very large. Okay. This is large distance. So they will not create electric field. The electric field created by A at the location of B can be neglected, and vice versa also can be neglected. Now the ratio of electric fields at the surfaces of spheres A and B. Okay. So electric field here, let me call it EA, and at this position, let me call it EB. We have to find EA divided by EB. This is what they are asking us. All right. So potentials are equal. Let's say the charge here is QA and charge here is QB. So what I can do here is potentials are equal. So K QA by R1, K QB by R2. Okay. And now what is the electric fields? The electric field will be K QA by R1 square, and here K QB by R2 square. And we do not need QA and QB. We just need the answer in the terms of R1 and R2. So I'm trying to eliminate QA and QB. Now QA by QB can be written here from here as R1 by R2. So QA by QB can be written as R1 by R2, and if we substitute that, the answer is going to come as R2 by R1. So this seems to be the correct answer here. So option B. So here I believe the answer is option B. Okay. So this section contains how much marks per question? This contains 1 mark each. Okay. So for 1 mark, fairly decent calculation, but okay, doable. All right. Let us go to the next question. Okay. So this question says a long straight wire of circular cross section A carries a steady current I, uniform, and this is distributed uniformly across the cross section. So there is a wire. Okay. This is a wire, and it is carrying current I. All right. Uniformly throughout the cross section. It is carrying current I uniformly throughout the cross section. We need to find the magnetic field at a distance a by 2 from the axis of the wire. Now the formula for this is mu naught j r by 2, where this is the value of r and j is the current density. So I divided by pi a square. So let us put the values and see. Mu naught j I divided by, and r can be written as a by 2. So mu naught I by 4 pi a. So option C seems to be the correct answer to me. Option C seems like the correct option here. So what you need to know is you need to remember this formula. This must have been taught to you. All right, students. The next question. The next question is a theoretical question. Am I audible? Okay. Shape of the interference fringes in YDSE when the distance between the slit and the screen is very large. So, distance between the slits and the screen is very large compared to the slit separation. So, when this is the case, we have the general. This is our YDSE general assumption, okay, and in which we get straight lines. We know this. So, I think the answer here is straight lines. Coming to the next question, question number 5. Question number 5. An electromagnetic wave passes from vacuum into a dielectric medium. Okay. Vacuum into some medium, let's say refractive index eta, and relative electrical permittivity and relative magnetic permeability is given. So we know this formula is epsilon r into mu r. This is the formula for refractive index. So let us first find the refractive index. So this is 3 by 2 and this is 8 by 3. So this comes out as 2. Now the wave passes from vacuum to this medium. Okay. So what will happen? Wavelength, double, frequency, and so you should know this frequency only depends on the source. So frequency will remain constant. Okay. But wavelength will change as velocity changes. So we know velocity is written as c by refractive index. So velocity in vacuum by velocity in medium equals to refractive index of medium by refractive index of vacuum. Refractive index of medium is 2 and vacuum refractive index is considered as 1. So this is the ratio velocity of wave in vacuum by velocity in medium, and velocity can be written as frequency into wavelength. Now frequency doesn't change but the wavelength will change. Okay, frequency doesn't change but the wavelength will change. So uh, from vacuum into dielectric medium. Okay, so wavelength medium by wavelength vacuum will be 1 by 2. So wavelength is halved. Wavelength is halved. Okay, wavelength is halved and the frequency remains unchanged. So option C should be the correct answer. I think option C should be the correct answer here. Going to the next question, question number 6. In a series LCR circuit, the voltage across the resistor, capacitor, and inductor is 10 volt each. If the capacitor is short circuited, the voltage across the inductor will be okay. So, so we have a this pattern of circuit. Some supply voltage is there, okay, and each have voltage drop 10 volt. So if I were to draw the phasor diagram, voltage across resistor, voltage across inductor, voltage across capacitor, all three are 10. So if you see here, the net voltage, this are going to cancel, so the net voltage is here, net voltage is 10, okay, and here we are talking about the RMS values. If nothing is given, it is the RMS values. Now the capacitor is short circuited, okay, so the next time what we do here is we are going to short circuit this capacitor, so there is no voltage drop, so capacitor we have to ignore now, so it is just now LR circuit, okay, so the circuit now becomes something like this. Voltage across the inductor will be okay, this they are asking. Now we know that the supply voltage is 10 from here, we know this, the supply voltage RMS values is 10, and now we will have this and inductor, only this two we are going to have, all right, only this two we are going to have. And from here, as the voltages were equal, we know this is IR and this is IXL. Since they have the same current and they had the same 10 volt across the resistor and the inductor, that means R and XL were equal. That means VR and VL will be equal here also. All right. So if this is X, then this will also be X. Now the net voltage, their net voltage is given as 10. Okay. So this 10 can be written as the sum of these two. Okay, vectorically. So root 2x. So x becomes 10 by root 2. So the answer here seems to me as 5 root 2. Okay, I'll say this question was a little tricky. So I think option B is correct here. Option B seems correct to me. Okay, the next question is theoretical. Electromagnetic waves used in diagnostic tool in medicine have a wavelength range. So here I think the answer should be 1 nanometer to 10 to the power minus 3 nanometers. Okay, this is what I feel the answer should be. Because see, 1 mm to 7700 nanometer should not be, zero point 0.1 meter to 1 mm should not be the answer. 400 nanometer seems quite specific. Okay, so even if I do not remember the value, then also I can guess it, and I think the answer should be option A. All right, going to the next question. The distance of closest approach of an alpha particle is d when it moves with velocity v. Okay, head on towards the target nucleus. If the velocity of alpha particle is half, the new distance of closest approach will be. So in this type of question, you don't have to calculate the exact answer. You just have to compare. Okay. So distance of closest approach. So you must know this. If a charged particle is projected towards another charged particle, okay, with some velocity, it will get repelled, 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 and finally come somewhere at rest. Then this distance is known as the distance of closest approach. Hmm. And generally, if nothing is mentioned, we consider initial distance as infinite. Alright, now we just need to do energy conservation. So this energy, kinetic energy, got converted into potential energy. So we just need to see the relation here, inversely related with the distance, the distance of closest approach. Now when the velocity is half, the new distance of closest approach. So it's v final v dash by v whole square equals to d by d dash. Correct? D by d dash. Yes. So this should inversely related. Velocity is halved. So v dash is v by 2. So this is 1 by 4 d by d dash. So what is the new distance d dash? So I think the answer is option D. I think the answer here is option D. Okay, next question. So question number 8 was a fairly simple question. Question number 9, concave lens of focal length 10 is cut into two identical plano concave lenses. The focal length of each lens will be. Okay. So we have a concave lens. This focal length is given as 10. It's minus 10. Okay, that's fine. It's cut into two identical plano concave lenses. Okay. So let us say any one plano concave lens. If I cut it, then this is any one plano concave lens. Focal length of each lens. ओके मैं तो कमेंट्स देख रहा हूँ. इजी इजी ये सेट वन नहीं है. पता नहीं यार, मुझे तो यही बताया. इससे इजी पेपर ही नहीं हो सकता. इजीएस्ट पेपर एवर. सीक्रेट लेजेंड. ठीक है भाई. ओके, किसी ने कुछ पूछा. सर रिलेटेड लिख आया हूँ जो मेरे से नहीं हो रहे थे. नंबर मिलेंगे. करेक्शन करने वाले के मूड पर डिपेंड करता है. ओके. So cut into two identical plano concave lenses, the focal length of each lens will be. ठीक है, कर सकते हैं इसको हम. So concurrence, we'll consider them like this. Okay, R and R. अब R और ये रेडिया इनफाइनाइट हो गया, इसके लिए एक्सप्रेशन क्या बनेगी हमें पता है, 1/f इक्वल्स टू म्यू ऑफ लेंस बाय म्यू ऑफ सराउंडिंग माइनस 1/r1 माइनस 1/r2, ये रिश्ता होता है ना भाई। तो इसके लिए इक्वेशन क्या लिख सकते हैं हम, 1/-10, ये वाला को एक कांस्टेंट जैसा सराउंडिंग को 1 मान लेते हैं, चलो थोड़ा लिखने में इजी रहेगा। एंड दिस वी कैन राइट r1 इज माइनस r एंड r2 इज प्लस r, तो ये दिस कैन बी रिटन लाइक दिस। ओके, आप लोग बीच बीच में कमेंट्स कर सकते हैं, ठीक है, थोड़ा बातचीत होनी चाहिए। सो ये एक एक्सप्रेशन मिल गया मुझे। दूसरे वाले का लिखते हैं, लेट्स राइट फॉर द अदर वन। इसके लिए क्या लिखेंगे, इसके लिए 1/f डैश, पता नहीं क्या है f डैश, वो निकालना है हमें। 1/infinite minus 1/r, so this seems to me minus 1/r, yeah. तो आई थिंक ये -1 ये 2 को नीचे ले आए, if we bring this 2 downwards we'll have the exact same expression, so this seems -1/20, so the focal length of each lens is -20. This seems to be the correct answer here, -20, and option में +20 is given, so option A seems to be the correct one. सेट 1 के एमसीक्यूज बहुत टफ थे भाई, लेंथी भी। अच्छा, अनुज शर्मा, हेलो हेलो जी। Okay, let us move to the next question. Four independent waves are expressed. Y1 equals to A sine omega t, Y2 equals to A2 sine 2 omega t, Y3 equals to A3 cos omega t, and Y4 equals to A4 sine omega t plus pi by 3. The interference between two of these waves is possible in, देखो interference pattern, interference is possible in every case, ठीक है, but the interference pattern will be visible if the sources are coherent, that is they have the same omega, ठीक है। So the question seems a little tricky here, okay, because technically interference is possible between any two waves, right? Incoherent sources also, they do interfere, they do interference, but the interference pattern is not visible. तो आई डोंट नो व्हाट टू से हियर, ठीक है, आंसर तो होना तो चाहिए ऑल ऑफ देम, ठीक है, आई थिंक आंसर शुड बी ऑल ऑफ देम, बट आई थिंक CBSE what they want to ask is which interference patterns will be visible, okay, and then that if they are trying to ask which interference patterns will be visible, then it will be option C, 1, 3 and 4, because they have the same omega, but actually interference can happen between any two waves. All right, next question. Two heaters rated as P1V and P2V are connected in series across a DC source of V2 volt, V by 2 volt. The power consumed by the combination will be, okay. Two heaters are there, consider them like resistors, okay. So this is P1V and this is P2V. So first we should find the resistances R1 and R2. So power and voltage have this relation between them. So resistance becomes V square by P. So R1 is V square by P1 and R2 is V square by P2. Now they are saying they are connected across in series across DC with the power consumed by the combination. Okay. So power of the combination. They are in series, okay, and across a voltage of V by 2. So again we will use V square by R formula, but here instead of V we have V by 2 square, and here instead of R we have R equivalent, which will be R1 plus R2 as they are in series. V square by 4, R equivalent R1 plus R2. So V square by P1 plus V square by P2. V square can be cancelled. 1 by 4 P1 plus P2 by P1 P2. So P1 P2 by 4 P1 plus P2. So option D. Option D seems to be the correct answer here. Next is, in an unbiased p-n junction at equilibrium, which of the following statements is true? So diffusion and unbiased, no battery is connected. So diffusion and drift current, they balance each other. It is in equilibrium. Okay. So option C. Next are some assertion reasoning questions. First is if accelerated electrons are passed through a narrow slit, if accelerated electrons are passed through a narrow slit, a diffraction pattern is observed. Yes, true. Electrons behave as both particles and waves. True. Correct explanation also. Then we have mass of nucleus is less than the sum of the masses of its constituent nucleus. Correct, because some energy is released as binding energy. Okay, so mass of nucleus is slightly lesser than the exact sum of the masses of the nucleons. Reason given is energy is absorbed when nucleons are bound together to form a nucleus, which is incorrect. So here assertion is correct, reason is incorrect. In Bohr model of hydrogen atom, the energy levels are discrete and quantized. Correct. Reason, in a hydrogen atom, the electrostatic force on the electron provides the necessary centripetal force to it to revolve around the nucleus. No. So it is correct. Reason is correct, but I don't think it is the correct reason, because why do they occupy discrete energy levels? Okay, because the reason what they said that it was given by Rutherford also. So the reason, actual reason for assertion should be because the electron creates standing waves, okay, in the stable orbits. So the energy is trapped. Okay. Going forward, okay, section B now. We are going to section B. Photoelectric experiment, emitter plate is irradiated with radiation of 200 nanometer. Okay. Photo current becomes zero when the collector plate potential is this much, minus 0.8 volt. Okay, they have given us stopping potential and they have given us the lambda. Calculate the work function. Okay, this question number 17 can be easily done. You must know this relation. This can be written like this also. By lambda in nanometer, it is given as 200 nanometer. Work function plus, now we don't write E, we just write it. Okay, EVS. They have, so this is an electron volt. Yes. So if you just write this in voltage, we'll get the answer in electron volt. So this is 0.8. Solving this, you will get the value of this. and you'll directly get the answer in electron volts. Simple question. So next question number 18, they have given us a choice. Okay, there are two questions in it and one we have to do. Um, okay, both are similar type of question. Okay, but one is single slit and one is double slit. So let us do the double slit one. In a Young's double slit experiment still set up with slit separation this much given, a beam of light consisting of two wavelengths is used to obtain interference pattern on a screen cap this much away. Find the least distance from the point from this, the central maximum where the bright fringes due to both the wavelengths coincide. Okay, so we're going to do 18b. And this question, no, this 18b question, it has been asked in a NEET exam multiple times. This similar pattern question. So they have given us YDSC. All right, and there are two wavelengths, lambda 1 and lambda 2. They both will create their own interference pattern. They both will create their interference pattern which will overlap. So somewhere their bright fringes will also overlap. So for bright fringe, let's say let nth bright fringe of lambda 1 and mth bright fringe of lambda 2 coincide. So y, this y can be written in terms of lambda 1 as n lambda 1 d by d, and in terms of lambda 2 m lambda 2 d by d. Okay, now you just need to solve this. You just need to solve this. You'll get n by m from here. N by m आपको मिल जाएगा, and you take the least, you make this, reduce the fraction. Okay, don't take in decimal, reduce the fraction, and you get the value of least integer value of n or m. Okay, once you get this, then y can be easily calculated either by n lambda 1 d by d or m lambda 2 d by d. Okay, it's a fairly simple question. Okay, another question we are seeing here is, what is the order of magnitude? Okay, sorry. All right, so next question, the order of magnitude of drift velocity of electrons is 10 to the power minus 3 to 10 to the power minus 4 meter per second. Deduce the relation between the current flowing through a conductor and the drift velocity in it. So this is a normal derivation, I equals to n e a v d. So this derivation can be easily done. Okay, you must have done it in your class. Next is draw a plot of potential energy of a pair of nucleons as a function of their separation. So if you have seen this graph, it's something like this. All right. What right to important conclusions that can be drawn from this plot. Now we know that force is minus du dr. And here, if you see DODR is positive, so the force is here negative, attractive. Okay. And at this point, the DODR, the slope is negative, so the force is positive. So negative force means attractive force, and positive force means repulsive force. So after a certain distance, okay, before a certain distance, the force between the nucleons is repulsive, and after that distance, the force becomes attractive. And this is the nuclear force, by the way. Okay. So ठीक है, generally they do not ask so much, but they have asked. Okay. Section C. Going to section C now. Using Gauss law, deduce an expression for electric field at a point due to a uniformly charged thin plane sheet. All right, this derivation is done in classes, so I think it can be easily done. Derivation using Gauss law. It's a very popular question. Next is two large thin plate sheets, each having surface and plate to each other and say what is the net electric field. Again, a derivation. Okay. Obtain the condition of balance of Wheatstone bridge. Okay, Wheatstone bridge, they have asked the balancing condition. Very good. Net resistance of the network of resistors. Okay. One question is this. Okay. 22B. So one of the questions is this. Okay. This R. So this is Wheatstone bridge. Okay. You can tell, I hope. So equivalent resistance between A and B we have to find. So this is obviously Wheatstone bridge, but let me redraw the circuit. So A, then this is 2R. Okay. This we will draw in the form of Wheatstone bridge. And then B, this is 3R. Now let me say this is M and this is O, this is P and this is N. So all relations have R. So this is gone. Okay, now we have to find the equivalent. The equivalent now easily can be done. So this is R and R becomes 2R. R and R becomes 2R. 2R and 2R in parallel becomes R. Now all three are in series. 2R, R and 3 are in series. So R equivalent becomes 6R. I think this is the answer. Alright. Next question. 23. A parallel plate capacitor of capacitance C has a dielectric slab between its plates. It is charged to potential difference V by connecting it across a battery. The battery is then disconnected. If the dielectric slab is now withdrawn from the capacitor, how will the following be affected? Ah, Alright. See, when the dielectric is taken out, okay, when the dielectric is taken out, what will happen? The capacitance will decrease. Hmm. And it is happening at constant charge. This is happening at constant charge, okay, because battery is disconnected. Now capacitance will decrease. When the slab is taken out, the capacitance will decrease. Energy stored in capacitor. Now, energy, since it is constant charge, we will use this formula to compare. Inversely proportional to capacitance. So, if capacitance decreases, energy stored in increases. Potential difference between the plates of the capacitor. Yes. So Q is constant. Q equals to CV. Q is constant. So potential difference is inversely related to capacitance. Capacitance decreases, so potential difference between the plates also increases. Simple question, not very tough. Okay. Question number 24. Next question. So they have given us two plates. Okay. Electrons are there. Okay, let me consider just one electron, and its velocity is given to us. Hmm. They are kept 2 centimeter apart, so this distance is given to us. This half of the distance is given. Okay, 1 centimeter. Each plate is 3 okay, this is 3 centimeter long. For calculate the potential difference between the plates. Okay, the beam goes like this. That means the electric field must be upwards, because then only the force will act downwards, right? And its acceleration will be this. Now you can relate this question with projectile. Okay, this question they have asked a little tricky question, but not very tough. The potential, we have to find if we find electric field, we'll get the potential difference, because electric field will be potential difference divided by 2 centimeter. You can convert this. Okay, you can convert this into meter and all those things. Now the formula, this is range, and the range can be written as v into time of flight. Time of flight is under root 2 h by a. This is h. Okay, 2 h by a. So the speed, so from here you will get the v is given, h is given, and acceleration. So here, from here you can get the value of acceleration. If you get the acceleration, you will get the electric field, and if you get the electric field, you will get the potential difference. Okay, for 3 marks. I think this is a little tricky. Okay, moving on to the next question. 25. They have given us a diagram here. So we have two diodes, D1 and D2, and the resistances are given 1 kilo ohm, 2 kilo ohm, 3 kilo ohm. They have given the voltage input is 12 sine 100 pi t. This is the input voltage they have given to us. During the positive half cycle of the input voltage, positive half cycle. So let's say this is positive and this is negative. So current will come like this. It cannot go here, reverse bias. So current will go here. And now current will divide. So current will go here also, here also. It cannot go here because the reason is this is higher potential, this is lower potential. Current will not go from lower to higher potential, so it will come here and then come back to the battery, the source. So identify which of the two diodes will conduct and why. So obviously D2 will conduct. Redraw the equivalent circuit to show the flow of current. Okay, we can redraw. Calculate the output voltage across the three resistors. This can be done by you. Okay, so if the input has its peak value, the voltage, you can calculate the voltage drops output across the three resistors. This is simple current electricity question. Now next is a theoretical question. Briefly explain the two important processes that occur during the formation of a p-n junction. During the formation of a p-n junction, depletion layer forms, right? The holes and electrons, they diffuse and create a depletion layer, region in the center, which obstructs the flow of majority charge carriers. Okay, but still diffusion current and drift current are there, and in an unbiased p-n junction they are equal. So you can explain this. Okay, next there is a question on total internal reflection. State two conditions of total internal reflection. Okay, very simple. And then there is a very simple question, okay, of TIR. I think you can do this. So I'll move on to the next question. Next is a paragraph type question. So section D, galvanometer. The first paragraph is related to a galvanometer. So okay, let us see the questions. First question: torque on the coil remains constant irrespective of the coil's orientation during rotation due to. So if you remember, this is which question number by the way? Question 29. Okay. So if you remember, uh, in a galvanometer, construction of a galvanometer, radial magnetic fields are there. Okay. Due to which the torque remains constant. So answer should be radial magnetic field, option B. The best way to increase current sensitivity, current sensitivity is given as NAB by torsional constant, right? NAB by torsional constant. The best way to increase current sensitivity of a galvanometer is by increasing the number of turns of the coil, increasing the area and magnetic. The best way I think is to increase the number of turns. Okay. Next, moving on, galvanometer has a coil of area. Area is given number of turns. The coil is rotated. The torque acting. Okay. Torque simple expression here is NIAB. So you just need to use the formula. You'll get the answer. There's one more question here. Yes. The galvanometer coil has a resistance of 15 and meter shows full scale deflection. Voltmeter. Oh, conversion to voltmeter. You know this. Galvanometer conversion to voltmeter. A shunt needs to be connected, and this is the voltmeter now, right? And it is used to measure potential. So, voltmeter V, the formula here is so Ig into resistance of galvanometer plus shunt. This is the formula for conversion into voltmeter. Galvanometer has a resistance of 15. They have given us this value 15. Meter shows full scale deflection for current 3 milliampere is this. We want to convert into a range 12 volt. This is 12. Now you can just put the values and calculate. Okay, quite simple question to be honest. Next is galvanometer of coil resistance shows full scale deflection. Now they are converting into ammeter. So for the conversion of galvanometer into ammeter, do you remember the diagram? Yes. So galvanometer and a shunt is connected in parallel. Now this entire thing is diameter. Okay, this entire thing is diameter. Current I comes, it gets divided Ig, I minus Ig. So what is the relation here? Ig into Rg is equal to I minus Ig into shunt S. Now they have given us this value for a current of this Ig also given 5 milliampere, ammeter of range 10. So this is 10, this is given. Now shunt can be easily calculated. Not tough, not tough, students. If you have practiced, these are very important topics. Not tough. Next paragraph is regarding the stopping potential graph versus the frequency. Okay, so next question relates to this stopping potential versus frequency, and they have given us two graphs here. A and B. So we have the frequencies f1 and f2, and here we have voltages v1 and v2. So they have asked the work functions of A and B. Okay, the relation here is HF equals to 5 plus EVS. So EVS can be written as HF minus 5. So Vs can be written as H by E into F minus 5 by E. So work from the graph, the work functions of A and B are. So we have to use y-intercept. Okay, so V1 is, let's say, 5 by E. So work function is EV1, and similarly the other one also we can do, right? कुछ गड़बड़ किया हमने? सही तो लग रहा है. Okay, for the radiation of frequency greater than V2. Did I draw the graph incorrect? नहीं सही है. Okay, the radiation of frequency greater than F2. Okay, incident on the surfaces A and B, the maximum kinetic energy is what? Okay, maximum kinetic energy is related with EVS. So if a frequency is greater than this, okay, greater than this, so who will have the more kinetic energy? Who will have the more kinetic energy? So if a frequency is greater than this, let me plot it like this. These are the two possible Vs. Obviously you can say the stopping potential of A is going to be greater. So the maximum kinetic energy of for the metal A is going to be greater. Next is if the intensity of the radiation is doubled, keeping the frequency constant, then slope will change, threshold frequencies will change, what will change? Okay. So if the intensity is doubled, keeping its frequency constant, so intensity doubled does not keeping this constant. This will not change if you change the intensity. It is independent. This will not change. Nothing will change. So I think option D. Slope of the parallel lines will not change, but more electrons will be emitted per second. Huh. Frequency causes more electrons to be emitted. Alright. Now we shall go to section E. Okay, section E31, electric dipole consists of 2 point charges separated by some distance. Derive the electric field expression. Okay, doable. Dipole is placed in xy plane such that charges q and minus q are located at different pose location. There is an electric field. Calculate the force and torque developed by the dipole. Yeah, quite doable this question. Next is two cells of EMF E1 and E2 with internal resistances R1 and R2 respectively are connected in parallel by connecting their positive terminals together and negative terminals together. Reduce the expression of EMF. This is a cells in parallel arrangement. Okay, derivation is quite simple. Next, parallel combination EMF this in this so that current flows through the resistance to R. Again, simple parallel arrangement of cells. Okay. 32. Using the relation for refraction at curved surface, spherical surface, derive the lens makers formula derivation. Okay, quite simple. Three lenses are placed coaxially. The distance between the lenses are given. Object is given. Find the distance of the final image. So 32. So three lenses are given to us. The distances are also given. Okay. I'm not going to solve the entire question. The focal lengths are same. Object is kept some distance to the left of L1, and this distance is also given to us. Find the distance of final image formed from the object. From the object, suppose final image is here, you have to find this distance. It's very simple. Okay, the process is very simple. First you calculate the image created by this lens I1. Suppose this image comes here. Okay, suppose this image comes, you will get this distance. You know this distance, so now you will get this distance. Now this image becomes object for this lens, so this lens will now create a image of this image. Let's say it creates here I2. Okay, so you know this distance from the lens formula, you know the total distance, you'll get this distance and repeat the same process again. This becomes an object for this lens, you apply the lens formula and you get the final image, this distance. Now you add all the distances and get the answer. A little lengthy, but as these are 5 marks questions, what do you expect? There is an alternative ray diagram. Derive the mirror formula derivation is an alternative to this. Okay, next I can see 33. They are asking state Faraday's law of electromagnetic induction. Nothing could be more simple. Derive an expression of self-inductance of solenoid. Solenoid derivation. Okay, self-inductance. Quite simple. You must know this. After that, draw a label diagram of a step-up transformer. Transformer you do know, right? Let me do it in another sheet. So transformer, we do know this. You just have to label it: core, primary winding, secondary winding, number of turns, all those things. Hmm. Draw label diagram step of the state the principle on which it works. It works on the principle of electromagnetic induction. Obtain the ratio of secondary and primary as the number of terms. Okay, you know this secondary voltage, primary voltage is proportional to the number of terms. Okay, and now the last is a question based on the same transformers. It's quite simple question. So with this we have come to the end of the paper. Okay, some questions were easy, some questions were a little tricky. I will read the paper as a moderate paper. Okay, not a very easy paper. Some questions required thinking, whereas some were quite fairly simple and expected type of questions. Okay, a moderate paper for all of you, and let's hope you get very good marks in the exam, and best of luck for the upcoming exams. All right, so thank you so much, students. Have a good day. Bye bye.